My name is Manfred Helber and I'm a Microsoft Most Valuable Professional in the category Cloud and Data Center. Before we start with the storage cluster itself, we want to use some time to speak about the storage architecture and storage concept in Azure Stack HCI to understand when we need a storage cluster and what are the advantages and maybe also disadvantages of a storage cluster. So Azure Stack HCI and the technology Storage Spaces Direct has a full redundant concept where the fault domain, so the entity that is protected by the redundancy concept, is the server. The fault domain is the server. This means that, for example, here we see a three-way mirror. The data is written in copies across the servers. It's not written on server 1 and then replicated to 2 and 3. We have this virtual layer, storage spaces, our software-defined layer, and when we write data, Storage Spaces Direct ensures that the copies are distributed across the servers absolutely synchronously. For sure, this happens via the local network, but important is to understand it's synchronous. It will never happen that you are able to write data to a Storage Spaces Direct cluster, traditional cluster, on Azure Stack HCI or Windows Server with Storage Spaces Direct in one side, and you lose any data on a node in cause of a failure, as long as you don't violate your redundancy levels or resiliency levels. We will discuss this in the next slides. So important is here in the three-way mirror, for sure you can lose server 1, you can maybe lose a drive in server 2, but you cannot use at the same time anything in server 3. So it's important that based on the resiliency level, we have defined how many simultaneous failures can be survived. Storage Spaces Direct strives the data for parallelism. So it's not only for resiliency and redundancy, it's also for performance. Because when you look at the performance values of Storage Spaces Direct in Azure Stack HCI, you will see great values like a 12-node cluster with 14 million IOPS per second. This was, I think, the last Storage Spaces Direct record. With today's available nodes, with the today available hardware, you usually reach up to 1 million or something like 1 million IOPS per second per node that you can scale with the nodes. To have this parallelism and to be able to build the redundancy across the servers, Storage Spaces Direct writes the data when we create a volume in slabs or extents with a size of 256 megabyte each. So what we see here is the process that happens when we create a volume. Here, for example, 1 terabyte size, and this volume with 1 terabyte size is cut off in slices in slabs of 256 megabyte in size. So a 1 terabyte volume has something like 4,000 of these slabs. These slabs are copied to ensure that we have the redundancy based on the redundancy level. So here we can see a two-way mirror. It's a two-way mirror. In a production environment, this is not supported for 3-node configurations. This is only here for the animation. So we see for each slab, the algorithm builds a copy, and the algorithm ensures that the server that has the original slab will not hold the copy related to this original slab. So we ensure that we always have a separation of original data and the copy. This concept with the slabs helps us to be flexible in adding servers, because if we add a server, we can use the rebalancing to rebalance the slabs across the servers. And so I can use 4 servers with three-way mirror. I can use the 5, 6 servers with three-way mirrors. Three-way mirroring starts with 3 servers. In 2 servers, we have the two-way mirror. And we have the nested resiliency. The nested resiliency is great because in the two-way configuration, in the two-server Azure Stack HCI cluster configuration, we have the situation if one server fails, we maybe also want to survive if a hard disk fails in the other server. And this is the situation when we have configured the nested resiliency, because then we can survive two simultaneous storage failures. So maybe one downtime for one server and at the same time a disk failure in the other server. I mentioned it with 3 servers, we have the 3-way mirror. With 4 servers, we have the 3-way mirror and the dual parity. It's now important to understand the redundancy concepts and to understand the situations where we need a stretch cluster is to understand that behind an Azure Stack HCI cluster, there's a cluster configuration like we know it in Windows Server 2022, 2019, 2016. So the basis for all this is a cluster. And the cluster has a concept that ensures that we always keep the quorum in the cluster. So the majority of votes, and each server in the cluster has a vote. Even if we don't configure storage spaces direct, if we only configure a server cluster, each server has a vote. And if anything happens in this cluster, the cluster tries to find out if you can build a quorum, so a majority of votes, with the remaining servers. Let's have a look at a 2-node cluster. We can see here in the headline 2 nodes without witness. The witness is an additional instance. It can be a file share or a cloud witness. And the witness also has a vote. We will see how important the witness is, because let's have a look at this 2-node configuration. Let's imagine both servers would have 1 vote and one server would fail. Then we have remaining 1 vote from 2 votes. This is not the majority. This is 50%. But 50% is not the majority. This means what happens in the cluster where we cannot build the majority of the votes, the cluster ends the running services to ensure that there will be never a split brain configuration where the services run on different nodes, and this is not a good situation. Let's imagine we have our Exchange server. We have one Exchange server. Because of a failure, this Exchange server suddenly runs on 2 nodes in the cluster. This will cause chaos in our data. This is the reason why the concept of a cluster says, okay, if I cannot build the majority of the votes, I'm not absolutely sure about the situation in the cluster. So to avoid chaos in our infrastructure, I will shut down all the services. So because this is, if we build a 2-node cluster without a witness, and if both servers would have a vote, it would be clear if one server goes down, the other server will also go down. So this doesn't make sense to have such a configuration. This is the reason why Microsoft says, okay, if the administrator does not know about the witness concept, or he forgets to configure the witness, or maybe he has a reason why he does not configure the witness, then we care about this and ensure that one server will receive a vote and the other server not. The situation is now that we have a 50% chance to survive one server failure. So in a cluster, we should not calculate with chances, but it's the situation here, and it's better than 100% guarantee that the second node will go down if the first node has a failure. So this means if server 1 fails, the server 2 will go down, or not the server, the services on the server 2 will be ended. If node 2 goes down, server 1 can keep all the services and there will be a failover to server 1 because the server 1 has 1 vote from 1 vote, so 100%. When you have a look back to the configuration module where we configured the 2-node cluster. At the end of the configuration, we had a cluster configuration report that said, oh, you have to care about the witness yourself. I will not configure the witness for you. And we configured a file share witness at the end. It would also have been possible to configure a cloud witness. We configured the cloud witness in the 4-node cluster. So let's have a look at the 2-node configuration with a witness. If there's a witness there, we can see, okay, now we have 3 votes. Let's imagine server 1 goes down, then we have 2 votes from 3 votes. It's the majority, it's the quorum. Let's imagine server 1 goes down, then we have server 2 with a vote and the witness. It's 2 votes from 3, it's the majority, it's the quorum. Let's imagine the witness goes down, then we have 2 votes. One from server 1, the second one from server 2, 2 from 3 is the majority. But when the witness is down, we cannot survive an additional node failure in this cluster. This is important to understand because the witness is only a file share or only an Azure storage account, but the witness is regarding this quorum in the cluster as important as a server node is. I often hear in a 3-node cluster, I don't need a witness because if a node fails, we still have 2 votes from 3. This is the quorum and everything is fine. Yes, but when we have 2 servers that fail, for example, we have first the server 1 that fails. Yes, we can survive this. But then we have a concept that is called dynamic quorum. The dynamic majority set. This means if server 1 has failed, node 2 and 3 see, okay, we have 2 from 3 nodes. We can build the quorum. But then the cluster says, now I'm in reduced 3-node cluster. I have remaining 2 nodes. I have to remove a vote from one of the nodes to ensure that I have a 50% chance to survive the next failure. And we already discussed, to calculate with chances, it's not a good idea in a cluster. So we should also configure a witness in a 3-node cluster, because the witness will not have a vote if the nodes are all up and running. If one of these nodes fails, then the 2 remaining nodes, so let's imagine node 1 fails, node 2 and 3 would say, okay, we have 2 from 3 nodes, we can build the quorum, and then the witness will receive a vote to ensure that we can survive the next failure here in this cluster. This means please always configure a witness, not only in the 2-node and 4-node clusters, because here we have again the situation, if we have only if we have 4 servers without a witness, 1 server will be configured without a vote to ensure that we can survive a situation where maybe 2 failures fail at the same time. Let's imagine these 2 servers fail, then the first 2 servers can survive. But if the other 2 servers fail, these servers on the right-hand side cannot survive because they only have 1 from 3 votes. Better situation is to have a witness, because then we can survive a failure of node 1 and 2 at the same time, 3 and 4 at the same time, 2 and 3 at the same time, and so on. So always configure a witness to be sure that you can survive the maximum amount of possible server failures within your cluster and still build the quorum. Witness types I already mentioned, a cloud witness or a file share witness. For traditional SAN-based clusters, there's also a disk witness, but this is not supported in Azure Stack HCI, where we use storage spaces direct. So this is important to understand, and it's important to see that a witness must not be on any of the server nodes, because then we would again put an additional vote on this node. A witness has to be an independent source. The best choice is the cloud witness, because there we always know we are not the Azure data center. The Azure data center is at Microsoft. This is a different location. If we use a file share witness, please do not put this file share on any of the server nodes. And the file share itself also is not a high available source, because imagine the witness is split via two sides and one side goes down. And because you have configured a high available witness, the witness goes online at the second side. This would not be a good idea. So the witness should always be in an independent location. If you are working with servers in the same rack, the witness should be on another server than the nodes. If you are working with different server rooms, then the witness should be not in the same server rooms with the nodes on room 1 and room 2. So it depends on your architecture, on your scenario, where we should place the witness, never on the fault domains. The default fault domain is the server. If you have different data centers, your fault domain will be a data center and maybe inside the data center, the server. Now in Storage Spaces Direct in Azure Stack HCI, we have an additional very important point we have to care about. It's the pool quorum for the disks. The pool quorum in Storage Spaces Direct says that we always need the majority, the quorum of the disk drives in our Storage Spaces Direct pool. So we independently from the cluster quorum and from the resiliency level we have configured, we can survive maximum 50% disk failures in the pool. If more than 50% of the disk drives fail, then our pool will go down. This does not mean that we have automatically a data loss. This can be a data loss, but it's a downtime. This is important to understand, because usually you build a cluster to avoid any data loss and to avoid any downtime. In a Storage Spaces Direct pool, the pool quorum also knows votes. So every disk has a vote, and there's a pool resource owner. This is one server in the cluster, that's the pool resource owner. And this pool resource owner has one additional vote. So if we have the situation we can see here, 2 nodes in the 4-node cluster fail. We have 50% of the disks. This is not the quorum, but we have an additional vote for the pool resource owner. If the pool resource owner fails, here in this graphics, the 2 servers fail, there are not pool resource owner. If the pool resource owner fails, the cluster checks if there's a server available that can become pool resource owner. And usually this is possible. If we have 2 nodes in a 4-node cluster that fail, the second 2 nodes already keep the pool resource owner, or one of the 2 nodes can become the pool resource owner, and then this can check if they can build the quorum in the pool. So it's important to understand this, and it's important to understand that even we have one pool in Storage Spaces Direct cluster in Azure Stack HCI and one pool resource owner, every node can read and write from the volumes in the storage pool at the same time. So this does not mean that this pool resource owner has some exclusive access. What we cannot survive regarding the pool quorum is the situation that maybe 2 servers fail and an additional disk drive fails. Because in this situation, we have less than 50% of the pool quorum votes, and this means the pool will go down. Additionally, we have to think about the resiliency level. Keep in mind, in a 3-node cluster starting, we have the 3-way mirror. So in this 4-node cluster we can see here, we could also have a 3-way mirror, so we can survive 2 simultaneous storage failures. So let's imagine we have a different situation. We have this situation, but we don't lose the servers, we only lose drives. So we lose a drive in the server node 3, a drive in the server node 4, and we lose a drive at the server node 2. Then we have the situation that our pool quorum stays online. So imagine these 2 servers didn't fail, so they are still online. Let's use a color here to show this. So this server is online again, it's up and running because of some failure situation. Because of some failure situation, we have in each server a disk drive that fails, and then another disk drive fails in the server node 2. Then our pool stays online because we have the majority, we have the quorum in the pool. We have 13 disks from 16, this is the quorum, and we have the pool owner. So we have 14 votes out of 17 votes. This is the quorum. But we violate our resiliency level, which is in 3-way mirror. So if we lose 3 drives in 3 different servers at the same time, then they will see that the volumes go offline, the pool stays online, and we usually will see some data loss here. So let's discuss how many servers can fail in an Azure Stack HCI configuration at the same time. The interesting thing is, in a 2-node cluster, we have this nested resiliency. This means if in this configuration with 2 nodes, 1 server fails, we can survive an additional disk failure in the second server, but only 1 disk failure. So this is really great about the 2-node configuration if you have configured the nested resiliency. In a 3-node server, in a 3-node Azure Stack HCI configuration, 1 server can fail, and 50% of the disk drives, this should be 50% here of the disk drives, they can fail maximum to ensure that the pool stays online and the volumes stay online if they are configured with a 3-way mirror, but this is the default value in a 3-node cluster. In 4 nodes, still the 3-node resiliency, the 3-way mirror, and we can survive the failure of 1 node, and we can survive the failure of an additional node, because here we still keep the quorum of the disk drives, we still keep the quorum of the cluster. Each of these clusters has configured a witness. This is important because if there's no witness configured, it's a different situation. But I mentioned we always should have a witness, so we have a witness configured here. So in a 4-node cluster, we can lose 2 nodes, but no additional disk failures are allowed here. So we cannot survive any additional disk failure. It's the same with 5 nodes. You can lose 2 of them, but no additional disk failures. Or maybe you think, okay, if I have a 5-node cluster and I lose 50% of the disk drives in the next node, I have still the quorum in the pool. This is correct. The pool will stay online even if I lose additional disk drives, but my volumes will go down, will go offline, because I violate the resiliency level, where the maximum resiliency level is starting with the 3-node cluster, the 3-way mirror. In the 2-node cluster, we have the nested resiliency. It's the same in the 8 nodes. We can survive when we think about the quorum of the cluster, the quorum of the drives in the pool and the resiliency level, we can survive maximum 2 failures at the same time. It's the same here for the 16 node cluster. So starting with the 3 node cluster, the resiliency level cannot be increased. And starting with the 4 node cluster, the maximum survivable node failures cannot be increased. So with additional nodes, 5 node, 6 node, 7 node, we only increase our storage efficiency and storage capacity, and for sure also our CPU memory resources. So here we can see the fault domain is the server. I mentioned this. The data is distributed, is written across the servers to have a redundancy across these fault domains. Storage Spaces Direct supports since the first version in Windows Server 2016 the option to configure different fault domains, to move from a node or server fault domain to an chassis or rack or site fault domain. The advantage of changing the fault domains is that now the slabs are distributed differently. Till now we have learned that the slabs are distributed across the servers and the server is the fault domain. When we build, let's say, a rack fault domain awareness, we can build something like this. We have 4 racks, and in each of these 4 racks we have 4 servers. This is the maximum configuration for a Storage Spaces Direct cluster, also in Azure Stack HCI. So maximum 16 servers in this cluster. And we have configured the fault domain awareness on the rack basis. With the fault domain awareness, we explain Storage Spaces Direct. Okay, server 1 to 4 is in rack 1, server 5 to 8 is in rack 2, and so on. And now Storage Spaces Direct distributes the slab in another way than in a cluster where the server is the fault domain. Here we can see the slabs, the extents, are distributed across the racks now. So Storage Spaces Direct sees each of these racks with 4 servers as one entity. And now, in this configuration, we could survive the outage of a complete rack where we have 4 servers. On one of the previous slides, we have learned that we cannot survive this in Storage Spaces Direct. Now I explain you we can survive this when we configure fault domain awareness. It's true. This is the situation because the slabs have a new way how they are distributed because they see different entities, they see different fault domains here. The important thing is to understand that this configuration is not supported for Storage Spaces Direct in a production environment. So from the theoretical possibilities, it's there. I can configure this fault domain awareness. But when we read in detail through the architecture, then Storage Spaces Direct in Windows Server and Storage Spaces Direct in Azure Stack HCI requires to have all the nodes in one rack. It requires to have a local network with optimized and low latency between the nodes. There's actually no public document I know about where we can read what the latency should be. Because you can imagine the latency varies depending on the media type you use. Do you use copper cables or optical cables? It depends on your network technology. Do you use RDMA, what I strongly would recommend, or are you working without RDMA? There are vendors of RDMA cards that have a focus on latency optimized communication. These are all factors. If you choose the best medium optical cable, the best NIC card, RDMA with optimized latency optimized traffic, you maybe will have a smaller latency across the racks here with several meters between than in a single rack configuration where you use copper cables without RDMA capable NICs and with a loosey configuration regarding the latency. But this is not part of the documentation that you have this varies. The documentation says the nodes of an Azure Stack HCI cluster have to be configured in one rack. So this is only a theoretical option. You can configure this, but you do this on your own risk. Regarding the written documentation, you will not have support for that, what you can see here. It's an example in the documentation, but if you put all your knowledge in there and you read through the complete documentation, you will see this is not supported. And if you want to build something like this, because you say, okay, I have servers, I have many servers, and I want to survive more than 2 simultaneous node failures, or I have 2 sites. Maybe I have a data center in one location and a data center in the other location. Then you will need to configure a stretch cluster. And a stretch cluster is only available in Azure Stack HCI. We don't have stretch clustering in Storage Spaces Direct with Windows Server 2022, 2019, or 2016. So stretch clustering is one of these exclusive features we have in Azure Stack HCI. A stretch cluster can be active-active, and a stretch cluster can be active-passive. What's important to see, we have in a stretch cluster 2 storage pools. A stretch cluster is one cluster. It's one cluster with minimum 4 nodes. We discussed that Storage Spaces Direct can start with 2 nodes, but a stretch cluster starts with minimum 4 nodes because we need 2 nodes in one side and 2 nodes in the other side. We will not build 2 clusters. We will build one cluster, one stretch cluster, but we have 2 storage pools, one inside one and one inside 2. And this is the reason why we can survive more simultaneous failures in a stretch cluster, because now we have another situation how this pool quorum works. We have still all the requirements we have heard about, but if we lose pool quorum inside one and the pool goes down, and because the pool goes down, also the volumes go down, we have still the side 2. And in the side 2, we have 2 servers where we can survive additional failures. Because inside 2, we also can lose one server without losing the pool quorum, without violating my resiliency level. This is important to understand that the stretched cluster, there's stretched in the name, but one reason to build this stretched cluster is really the distance, because in the stretched cluster, now we have a support for more latency between these 2 sites. So we can here survive more latency. So there can be some distance between these 2 sites. We will discuss this in a few minutes. And we can survive more simultaneous failures. So a stretch cluster could also be an option for you if everything is in one side, but you have the situation that you say, okay, I need to survive additional storage failures in my environment more than we have discussed before. But what we also have to keep in mind, and what you can see already on this graphic here, a stretched cluster is more complex than a traditional Azure Stack HCI cluster. We had 3 lab modules where we have built an Azure Stack HCI cluster, one with 2 nodes. We have built a 3-node cluster, a 4-node cluster. It was always very similar. Were understandable steps. In this stretch cluster configuration, we first have to decide, will it be an active-active configuration or an active-passive configuration? In an active-active configuration, we will have virtual machines running on each of the sites. So this virtual machine will run here, and in case of a failure, this machine will start here. And we have also virtual machines up and running on the second side. And if this machine here on the second side fails, or the second side fails, this machine will be started on the left-hand side. So both sides active configuration. We use both sides for workload, and we have the other side for failover. In the active-passive scenario, we define one active side where all the workload is running, and the passive side is only there for failover. If you have this configuration, you usually will also look at the costs, and then maybe it could be an interesting option to think about using Azure Site Recovery instead of an active-passive Azure Stack HCI cluster. Because with Azure Site Recovery, you bring your virtual machines to Azure. You don't need this second data center. You don't need this second backup location because you're just using the Azure data centers. For sure, you also have costs of on each virtual machine you bring to this Azure data center, but you have to compare this for your costs for this second site here. Let's have a detailed look at the stretch cluster with an active-active configuration. Microsoft says in this active-active configuration, we have a synchronous replication of data consistent without zero data loss between the two sites. It's in synchronous configuration. It's active-active. Important, I didn't mention this on the previous slide. Between the storage pools, we have storage replica as a technique. So here, between the pools, we have storage replica. It's a different algorithm to what we are using inside one storage spaces direct cluster. Important is that for a synchronous replication, what we would use here, we require a limit of maximum 5 milliseconds round-trip network latency between the two cluster groups here, between the two sites. These are typically between 20 and 30 miles. This is between 35 and 45 kilometers. So something between 30 and 45 kilometers. You can have a synchronous active-active stretched cluster with maximum this 5 milliseconds round-trip latency. I mentioned, depending on your network technology you use, it might be higher. Then you maybe are not able to build it synchronous. But if you choose the best media and technology, this will be possible. So creating volumes in an Azure Stack HCI stretched cluster is a little bit more involved than for single-site clusters because we have additional volumes. When we create volumes using Windows Admin Center, we have the situation that we have additional volumes for the log data because storage replica needs a volume for its log information, for its logging information to provide this replication between the two sites. The cloud witness is also an important topic here because it's not a good idea to have the witness on this side or on this side. So the recommendation is to have the witness in such a stretch cluster in an independent third location. And the great opportunity is to use a cloud witness, because there we have the location in the Azure data centers. So the recommendation is for Azure Stack HCI cluster to use this Azure Cloud Witness to ensure that you have your witness in an absolute independent location, not in your site 1 and not in your site 2, but in an Azure data center. If you want to see how to configure a cloud witness, you can review the module about deploying a 4-node Azure Stack HCI cluster, where we configured an cloud witness at the end of the cluster configuration. In an active passive configuration, the requirements regarding witness and so on are absolutely similar, but we have the option to accept some delta between active and passive site. For sure, in the situation that my active site fails, I will have some delta in the data. I will have some data loss, but I can configure this with a higher latency and so more distance between source and target. Important in a stretch cluster is the network design, because we have some requirements we have to understand. First thing is, RDMA is limited to a single site and it's not supported for this cross-site communication here. So RDMA is in site 1 and in site 2, not for the storage replica traffic across the sites. The servers in the same site must reside in the same rack and layer 2 boundary. I mentioned this when I showed you the option to configure the fault domain awareness. I had this picture with the racks, and I described you that this is not supported to have servers in one cluster that is not stretched in different racks. The host communication between the sites, so between site 1 and 2 we have in this picture, must be cross layer 3 boundary. The stretched layer 2 topologies are not supported. For sure, we need bandwidth to run our workloads. Bandwidth is the key to success here in stretch clusters, to ensure that we have enough bandwidth to transfer our data via storage replica to the other side. The recommendation is to provision 50% of the network capacity to have enough capacity reserve for example, failover scenarios. The replication between sites should use same NICs as the local storage. If we use the redundant adapters, we have to use set teaming, and we can separate the traffic on the logical layer. Between the sites, they can be physical or virtual adapters. They must have their own virtual LAN to route the traffic correctly. RDMA must be disabled on these intra-site adapters, and these adapters must meet any requirements for storage replica, because you have seen the technology that's used between these two sites. It's storage replica. When we look at a network configuration example, we can see the complexity here, because we have our network interface cards for the SMB traffic inside the cluster, and we have our network interface cards for the stretching. Here in this picture, we have site 1 on the top and site 2 on the bottom, and between we have our WAN. We have the top of the rack switches. You can also see in a stretch cluster scenario, the number of switches we need increases, because we cannot use the same switch here and here. It's stretched. There's some distance between. Now, if we configure this in an example, for sure you will use your own IP address ranges. We can see inside site A, we will use the physical NICs with the virtual NICs in this configuration with the SMB configuration mapped to the physical NICs. This is possible with different VLAN IDs and IP subnets, and this traffic is for local site only. This is the same situation here inside site B. We have the configuration for the nodes. We have the NIC names for the virtual NICs. This is what we can see here, the SMB2 and the SMB1. We have the physical NICs that are mapped to this. We are using the virtual switch with the switch embedded teaming. We have the virtual LAN IDs. We have the IP subnets and the traffic scope for the local site only. So far, I think it's clear to you. This is what we also would configure in a separate storage spaces direct cluster in Azure Stack HCI without stretching. Now for the stretching part, we have to care about the stretch switches or the stretch NICs, the virtual NICs that are used for communication across these sites. So these are the virtual NICs that are responsible for the traffic that is routed via the physical NIC, via the top of the rack switch, via the physical NIC here, into this stretch adapter here. So this is the way how the flow goes. And here we have the situation that we have a traffic scope cross-site for these adapters, clearly. And we have different IP subnets. It's also clear compared to the local configuration. And we have the situation that we will also use the same physical NICs. This is possible via the switch embedded teaming. So stretch clustering is a great additional opportunity we have in Azure Stack HCI. It's exclusively there. Please keep in mind that these scenarios here we can see also in the official documentation of Storage Spaces Direct is for showing you what is possible with fault domains, but it's not exactly supported to configure it like this. If we need different racks, different data centers, we always need a stretch cluster configuration where we have seen this is available with active-active or active-passive configurations.